is 2020. We actively promote and encourage attendees with specific interest in emerging technology topics selected for each event. The event series is designed to drive and support both the local tech ecosystem based within Worcestershire and promote opportunities to a wider network to help grow the tech-based community for Beta. This is instrumental when it comes to recruitment windows for future tech-specific accelerator programs, which I'm delighted to let you all know that we'll be opening recruitment for Cohort 4 in the next 10 days. Cohort 4 will be campaigning hard to attract applications from more defined areas of technology, one being 5G. But to broaden in terms of industrial IoT, AI and edge computing. And this cohort will start with Beta next March. You can now begin to see how each tech topic offered in these talks will focus on areas of next generation commercial technology for a broad cross-section of industry supply chains. So a Q&A session will follow the talks today. So please send your questions in via the portal Q&A section, and these will be shared across the panel for responses. So for today's theme, 5G and the future of manufacturing. Recent research found that 3/4 of industrial companies believe that 5G is going to be a key enabler for their digital transformation in the next 5 years. As the opportunity for faster connectivity, greater security, lower latency, and network slicing has spurred significant demand within the manufacturing world. 5G is now being hailed as the solution for a myriad of manufacturing challenges, coping with exponential growth of connected devices and data traffic, communication latency, and increasing security and connectivity performance. To exploit 5G's potential to digitally transform manufacturing, industrial companies must now identify the areas where 5G can add strategic value, both in the immediate future and the longer term, to design the right implementation roadmap, as it were. And we hope today's Tech Tuesday content can help with some improved understanding, to highlight some real-time opportunities and areas which trigger ideas and potential collaborations. I'm going to hand over in a moment to Andy Mackenzie, who's Project Director for Worcestershire's commercial 5G testbed based at Malvern Hills Science Park. And this will lead to our other two contributors around the future of manufacturing and the integration and potential with 5G development. Andy will be joined by two of the Ericsson 5G Consortium Partners team, which also include BT for Worcestershire's testbed. Thank you, Andy. I'd like to hand over to Andy Mackenzie, Simon Evans, and Noel Dias from Ericsson. Thank you.
Thanks, Linda. Just let me check. Okay, if someone can nod, they can see a greenish slide. I'll know that I've got it right. Brilliant. Hi, everyone. I'm quickly going to show my face. When I agreed to do this 2 or 3 weeks ago, I'd planned that we would have moved house and everything would have been good, and I'd be sitting in my new house all ready to go. But as some of you may be involved in the madness of 2020, everything was delayed. So I'm sitting amongst boxes on a 4G service to make sure we do this talk. And it's really important, and I'm really keen to do it. And we've been really, really lucky over the last 2 years with what we've done on 5G. So more on that now, but I'm going to hide my ugly face for now. So as Linda said, we've got Simon and Noel, who are fantastic members of the Ericsson team, who've helped us a lot during our 2 and a bit year journey with the Worcestershire 5G project. And the titling of the project was always around productivity and always around Industry 4.0. And we've learned a lot from that. And I'm going to try and share that with you, try and share to you what we've done, what we're doing now, and what we hope for the future. So just as a reminder for people, and many of you will know this, there's lots of language used about 5G. People say it's not just another G, meaning it's not just 3G, 4G, then 5G. But importantly, it's really important to realize the sort of opportunities 5G can bring. It's vastly quicker than 4G. It can handle far more volume. It gives you much, much better, i.e. lower latency, and allows you, with the development of Internet of Things sensors, to have small sensors with phenomenal battery lives, 10 years, and do things in a completely different way. Often when I talk about this, I try and put it a bit like this. On the traditional 2G sort of Nokia brick style era of phones, it was all people talking. 3G, 4G has seen it move towards a sort of 50-50 maybe of people talking and applications, things like Uber, music streaming, all that sort of stuff, YouTube, anything like that. 3G, 4G has been the birth of that. 5G, I genuinely believe it's going to be machine heavy. It's going to be mostly machines, not so much discussion, not so many people on it. And in fact, if you think about it logically, for the speeds we're talking about with 5G, you really don't need 5G to run a FaceTime call, but 5G can do a lot of extraordinary things. I think best characterized at the bottom of the slide, you can have incredible densities of devices, which is really, really useful in an industry setting. And also, if you think in your own life, if you think of when there used to be events such as Glastonbury and things like that, where thousands and thousands of people are together, it would be very hard to make a phone call out. Well, with 5G, that just shouldn't be a problem because you can have much more density than would be possible before. So I always put this slide in, which is a bit of a rough and ready slide, but it's a slide taken in Malvern Hill Science Park on my own laptop, just fiddling around to show you the sort of numbers we're talking about. So when you hear EE and BT and O2 and others talk about high speed, that's the sort of speeds you can get. So you're downloading it pretty much a gigabit, you're uploading at 60 odd megabits, and your ping and jitter are, in this case, not as good as we might like them to be, but this is a test network that we're configuring, and we configure it for different things. And importantly, with 5G and in an industrial context, it's possible with the upload and download to tweak it. So for a consumer wanting to download and watch movies would be really happy with the figures I'm showing you there now. But in an industrial setting where you maybe want 4K cameras uploading lots of information, you can reconfigure the network and probably set it, say, 500 down, 500 up, that sort of thing. And that gives you the ability to be flexible on how 5G can operate. So I'm going to talk to you about what we've done over the last 2 years, and I'm going to go through it as shown on the screen now. So we were interested in, could we put 5G in a factory? That's essentially what it was all about. And then if we got it in a factory, would it actually work? And when we started out, no one had really tried this before, and it hadn't been done. So the challenge was, how would an industrially noisy, electrically noisy, essentially big metal box operate? And would 5G operate as it, operates in sort of free space in the real world? So what we did was we built our own core network, the core being the computing at the center of it that manages the traffic, manages the SIMs, manages the security. So we built our core in Malvern Hill Science Park because that's where we run out of. And then we went to the Bosch factory, and we went to a factory called a company called Yamazaki Mazak, and we made them as outstations for us as well. Importantly as well, we also connected up a company called Kinetic that some of you will no doubt have heard of, because we wanted to check security and test security of what we were doing from the early days. If there is a criticism of mobile connectivity, it can sometimes be that security is an afterthought and a bolt-on. But what we wanted to show and work and understand was that you could build security in at the beginning of 5G and make it hard and ready for industrial applications. So that's what we built. We built this network, which is our own private network, which is a term you hear a lot about. So a public network is obviously a Vodafone, BT, O2 style network, whereas we built our own version of that with our own core and our own outstations. That's what we built, and that's how the network was. So if we look at some of the use cases we wanted to check were use cases and allowing people to do things that couldn't otherwise be done on 4G and also had been tried in Wi-Fi and had failed. And what you're looking at here is a large milling machine in the middle of the Bosch factory. This machine, Bosch generate maybe, 5,000 boilers a week out of that facility, and everything for them is all about manufacturing excellence, about improvements, about lack of failures, about understanding how the factory works and making the factory more efficient. So we worked a lot with Bosch to say, how could we design sensors, design data loads that could work on a machine like that to monitor settings such as vibration, temperature, maybe the angle that something was going at, looking for things that were moving and changing, and be ready to either immediately stop the machine if something was wrong, so you don't make lots of faulty parts, or to work out, was the machine operating sufficiently well that we could afford to extend maintenance on for a bit and not shut the line down. So our whole story has been with the manufacturers all the way along is, you know what you're doing, you know how to build boilers, you know how to do that really well. We'll help you build network and an infrastructure that help you support you do that. This machine we're looking at, a DMC machine that we're looking at, from memory, is made in Switzerland. So if it breaks down, it's a real pain for the Bosch people. If it's not something simple, they have to get someone to fly in from Switzerland to repair it. So obviously, building big data sets on that and being able to understand what's going on is really important. And that's what 5G was able to offer. The bottom right picture shows a small sensor called an XTK sensor, which is a Bosch developed sensor that they were wanting us to try. And that's the sort of sensors we used in the early days of 5G as we learned what was going on. One of the challenges in an industrial setting is that many of the machines were looking to 5G enable, and we have 5G enabled. Some of them are 10, 20 years old and were never designed for any sort of connection to the internet even, or connection to 5G. So it's been a challenge to physically wire them up, physically power them, and physically stop the machines ripping the sensors off. So it's been a ergonomical challenge to make sure we can sense it and get the right data. So that's what the Bosch Stasis was about. In Mazak make very high-end CNC milling machines. They're the sort of machines that are used by, for example, companies like McLaren Formula One team, and they make potentially for them low volume but extremely accurate parts for them to put on the racing cars. Now, Mazak make these machines in Worcester, but they're sold globally. And one of the challenges that they have is the machines are sold, and they may be sold to people on the other side of the world. And as you can see from the control panel in the picture on the left, they are pretty complex beasts. So it's always been a drive of Mazak to see, can they provide some remote expertise to their customers, and can they use a sort of virtual, as a chap there's got on a Google Glass style attachment, so he can see what the gentleman is seeing in the remote site, so he can actually understand what's the settings, what's going on, what's the machine physically doing, and give advice and try and help them. Now, Mazak's real drive to do this was not to save money, which I'll come to in a minute, but it was about improving customer satisfaction and making sure that their customers get more out of the machines that they've spent a lot of money on. So Mazak had tried this before using 4G and various wireless solutions, and they found that they could maybe do a call with someone for 10 minutes potentially before it fell over, and it was really annoying and a bit jumpy. Using 5G and the sort of data rates and speeds I've showed you before, they were able to hold a completely seamless meeting with someone from afar and actually understand what they were doing. One of the many challenges and why you'd want to do that with someone like McLaren, potentially, admittedly, they're not terribly far away, but is the actual piece you can be milling can be very, very expensive. So if there's going to be an error and a problem with the milling, you really want to stop that early and stop either damaging the piece or damaging the machine. So that was really, really important for Mazak, and it was something that worked really, really well. I mentioned security. We were able, because we had our own private network, we were able to test it. We were able to see if we could interfere with it. We were able to see if we could knock it over by trying to jam it and see how it responded. And we were able to build services and test how that operated and actually assure ourselves that it was working well. One thing that we'll come to in a minute is 5G as a sort of entity, as a thing, it's not completely all mature yet. People are still developing, standards are improving, new frequencies are being released. So it's been really interesting to work with companies such as Ericsson and be able to show them, look, we've found this. Did you know that was like that? And then they've been able to either say, yes, it is, or that's covered off in a release, we knew about that, or actually to look and see how we design things. Because if you're a private network user potentially, and you're someone like Bosch, to stick to them, they might want to share information from factory to factory, and but they're not going to want to share that out on the public network potentially because it's their own IPR. So we've been really lucky to working with Kinetic, and at the end of it, Kinetic have launched services to the market for them to help offer test and assurance to people wanting to build 5G applications and wanting to take them to market. So particularly at Mazak were able to show an improving increase in productivity. Going back to my earlier point about Bosch are really interested in making great boilers and making them on time and making them a predictable way and not having wastage and improving productivity year in, year out, year in, year out. And they're not potentially interested in 5G just for the sake of it. They're interested in how it helps them improve that measurement. In Mazak, going back to my earlier discussion, it was quite simple in a way to get some numbers together quite quickly for Mazak. Before they had the ability to use 5G, literally someone got on a plane. I mean, clearly that would be difficult at the moment, but someone got on a plane and potentially flew around the world trying to help people either understand their machines better or to help fix them when they're broken. But for Mazak to be able to do that from remotely, i.e. for them to do it in their factory in Worcester, showed an immediate productivity saving for them because they could just have the one gentleman sitting at home, maybe dealing with 2 or 3 customers in a day, rather than 2 or 3 days travel to go and see one customer. The problem with statistics and numbers is you can always say, well, that can't possibly be right. But some of the early work done and some of the papers that we've contributed to have shown that if you were able to drive productivity up across the UK by the use of 5G and in sort of Industry 4.0 setting, it would make massive improvements in the output manufacturing for the manufacturing sector. And in fact, although it's early days, particularly when we started out, we're able to prove that 5G can be directly applied to help accelerate business growth and move things forward. So really important and something that's sometimes maybe underplayed, but actually can't be underplayed. It's really important that not just school leavers, college attendees and things, but actually older people such as even myself, we really need to upskill people and help people understand what 5G is, how they can get involved in it, and how they can help take it to market. I think it's often said that when 4G came to market, the UK was a bit of a laggard in terms of deployment of 4G nationally, and then maybe some of the services and killer apps that then arrived, maybe the UK didn't have the best run at that because others were ahead. On 5G, we've worked quite hard with Worcestershire College and some of the universities to say you really need to understand what 5G is, what it can do in a real setting, and how you can take that into your market and how you can add that into your lectures and lessons. And that's been really, really important to get the skills and training up and running. So I'm going to hand on to my Ericsson colleagues for now. Over to you, Simon.
Yes, thank you, Andy. So a few words from us then on why Ericsson were involved in this consortium and why we were delighted to be part of it in terms of providing infrastructure and services for the 5G system, that's the core and the radio, and why we think 5G in manufacturing and industry is really important to industries, but also to our traditional customers who are the communication service providers. And I'll do that by means of a quick introduction to Ericsson and then some of the business potential and analyst reports that I wanted to highlight. Next slide, please, Andy. So Ericsson in the UK, we might be known to many people through the mobile phones that we launched as Ericsson and then Sony Ericsson in the 1990s, I think. But Ericsson had more than 120 years history in the UK. The diagram is showing the factory at Beeston, which was owned by Ericsson at the turn of the 20th century. And it was from there we built fixed communication networks. So PSTN telephone exchanges from the early 1900s all the way through really till now we're providing fixed telecommunications. But from the 80s and 90s and now in this century, we're also providing 5G systems, mobile systems, I should say, starting with 2G, 3G, 4G, and now 5G in the UK. We're involved in all of the main service provider network deployments of 5G. And in the UK, we have more than 4,000 employees. So next slide, please. So I think most of the audience know this, but just an indication of what is 5G. So 5G builds from a consumer perspective on what we use today as mobile broadband or internet connectivity. And it builds on that with increased speeds and throughputs. In the consumer space, it also enables fixed wireless access. So if you don't have a cable connectivity to your home or a copper or fiber connectivity to your home, then it's possible for service providers to use 5G as a wireless means to provide you an internet service at your home. But the topic today really is the industry potential here. And like mobile was seen to be cutting the cords that we used to have in fixed telephony, then we see for industry, then 5G will be cutting the cords that we have in industry. And in terms of industry, there's a huge amount of fixed connections. And although some Wi-Fi is coming into industry and manufacturing, I think more than 80% of all cabling is fixed cabling in factories today. And cutting those cords introduces a lot of flexibility in terms of industrial process. In terms of industry, then there's the massive IoT type use cases, which Andy talks about the density of sensors, and that was used in the Bosch example. But we also have critical IoT, which points towards the low latencies needed for robotic control that we saw with Mazak, and perhaps also business critical situations for video monitoring, surveillance, etc., that comes into critical IoT. The enablers in terms of network are, just reading from the bottom then, the new bands that we have with 5G that gives us a lot more throughput. In Worcester, we've been using the mid bands, so rather similar spectrum bands are deployed in the commercial public networks. But we will be introducing sort of new bands supporting much higher throughputs than you saw earlier from Andy into Worcester in due course. Standalone 5G is the ability to create new topologies of networks. Today, networks are very centralized, and 5G will enable us to bring components of the network in and furthermore, entire 5G networks or cellular networks into customer premises locations and manufacturing facilities. In Worcester, we actually have the full 5G network located in the Science Park at Malvern Hills. Low band then gives us coverage, capacity and speeds I talked about, latency. Network sharing is important because these industries will be supported from a common technology and a common network. And network slicing enables us to provide and optimize the characteristics for each of the use cases that are running on this network. I think if we go to the next slide. Oh, I think we've missed one, have we? Okay. Can we go to the next one, Andy? Just the order is not quite as I expected. And the next one? Okay, if we could go back. Sorry, apologies for that. I was going to show a slide which was describing the appetite in industry. It was a Capgemini report. So I'm not talking to the slide that's on the screen now, but it was a Capgemini report that showed that within the UK there was a number of industries surveyed, and of them, 75% said that they would deploy 5G technology within 1 to 2 years of products and solutions being available. And we have seen quite a large uptake already in the UK. Technologies started to become available last year, and they're starting to be commercial deployments this year. A few that I can think of, apart from the test beds we've had with Worcester, we've also seen announcements for commercial networks, private networks, 5G networks with Ford and with Centrica in the UK, also Northumbrian Water, and I think there was a press release also for Belfast Harbour for a ports type application announced recently. So we see a lot of interest and energy, and we see a lot of requests for information coming from individual industries looking to put this technology into their businesses and provide the use cases that that are shown on this slide. So this slide is after D. Little reports that was done in conjunction with Ericsson that looked at 200 use cases and then clustered those use cases on the left-hand side of the diagram, and then looked at the business and savings potential of deploying those use cases across a number of industries, which is shown in along the top of the diagram. The reason we've highlighted manufacturing here is because the heat map is showing at the bottom there that manufacturing is important because it's covering off a number of use cases, or is covering off the majority of use cases. Health is very, very interesting, important as well, as is energy and utilities. But for a service provider providing these kind of services and developing these use cases, the manufacturing use case then can help drive the development of use cases that can be deployed across the other industries, such as automotive, agricultural, energy, etc., all the way through to retail and transport. In terms of the main business potential, in terms of savings or optimizations for manufacturing, then the heat map on the right is showing that video, automation are really the main use cases, and they're very typical type use cases in manufacturing as well. Maybe we could move to the next slide, Andy. Okay, so this slide is there's been a number of reports in terms of return on investment for deploying cellular technology in industrial situations. This is showing a single case. There are cases from Germany as well, but this is showing a Japanese manufacturing industry. What they did was that they looked at the potential savings and use cases that could be deployed in that factory. And one of the benefits of 5G, the 5G technology, and the purposes of developing it, was that it can handle multiple use cases. So we find that the business case for deployment is very much driven by a variety of use cases and not necessarily by a single use case. The return on investment was, in this case, 24 times over 5 years. We do see returns of investments between 10 and 20. This was particularly high, but in that sort of range, we see it across multiple analysis that's been done across multiple businesses. I think that's probably all I was going to say there, Andy.
Brilliant. Thank you, Simon. Really useful to get an understanding. And just to pick up on something Simon said, more on it maybe in a minute, is we're often asked, is there a killer application for 5G? And we've done what we've done, right? And it's, as I've described, it's a developing world. And we haven't yet found a completely killer app. But if there was something to say on it, as we just heard, you can layer multiple use cases onto a network. So rather than building a network that you might have done traditionally to support some robots or support a process, with a 5G network, because of the data loads it can stand and the densities you can get away with on it, you can really use that network as a multi-purpose network. So what are we doing next? Well, on that, we're continuing our work on with our good friends at Bosch and working with the Ericsson equipment we've described. And importantly, if you start at the right-hand side of this diagram, coming back to my earlier statements, it's really about providing useful, actionable data and information for the engineers and the people who run the plant. That's what they're really interested in. So jumping all the way to the left now, we're working on new use cases around the copper pipe bending machine. Again, as I described earlier, we're looking at machine, managing vibration, temperature, angle of bend, that sort of thing. And as 5G networks and modems, etc., appear more and more open, we're looking to use better and newer sensors to do that. Racking crash detection is something that a particular favorite of mine. So if you imagine in a factory like Bosch, They have very large floor-to-ceiling racks that people come along with forklifts, lift up big heavy items and move them around and take them to the factory. Well, sadly, sometimes things are not done that carefully, and the racking can have a bit of a thump, which means then they have to take the racking out of service and they have to try and assess what's wrong with it and then repair it. Whereas if we can set parameters for what a good drop with a pallet looks like onto the racking, as opposed to a bad drop that's damaged it, we can not only find out whether that's actually done it any long-term damage or not, but we can pick up maybe, is it the same person doing it all the time? Is it a training issue? Is it that forklift's got bad, leaky rams on it and it's dropping things a bit too difficult? So that's maybe quite a simple application, but builds on my point about you can have a network in to do something and you can use it to do something else. In this case, racking crash detection. And although that's an example we worked on for Bosch, that's clearly got utility across UK industry. Just have to think of the Amazons of this world, that they would be interested in something like that. And I guess the darling of our private networks at the moment down the bottom is our automated guided vehicles, which is essentially, imagine if you saw it, it can lift up a normal conventional pallet and busy off around the factory, taking pallets of boilers from one place to another place and then dropping them down and coming back to get the next one. And using the data sets we've got on the right-hand side, essentially Bosch have got 4 production lines and they've got 2 robots, and all the production lines work at different paces. So the robots can be told and managed where to go to collect the next set of boilers and where to take them, much more efficient than a human doing it, and frankly, much less boring for someone having to roam around with a pallet truck all the time looking for boilers. So that's what we're doing with them. What have we learned? Well, we've learned a lot. It's been quite hard sometimes to get access to equipment. There's been delays on availability of modems. There's kind of not much point in having a network if you don't have an edge device you can connect to it. So that's been a challenge. The new Ofcom spectrum, new frequencies and spectrum sharing has been really interesting. It allows us to have spectrum and anyone potentially can at very low cost, which is really interesting, and allows you to potentially build your own private networks out of it. It's been a lot about overcoming complexities. A lot of things that you would think would just work because that's what we're used to, just haven't worked. And it's been quite hard to understand why that is. And a lot of it's been down to developing standards. It's been really interesting talking to enterprise, talking to manufacturers, explaining to them what 5G is and why they should be interested and getting their feedback on that. It's also been interesting talking on the supply side and saying to suppliers of hardware, look, this is what we're trying to do. This is what we see for industry, and why we think on a supply side you should be interested in helping us support that. And of course, scalability. The level of effort to build the 2 use cases, the 2 sites we've done, plus the 3rd site being the security site. It needs to become easier than that and require less man hours of effort to install, and it is getting much better. Lessons learned 2. This is my own personal opinion on some of these ones. The marketing hype on what you could actually get physically then get was sometimes quite different. Getting hold of any modems and CPAs at all was really difficult, but that's now beginning to get a lot better. And it's a reality that the choice of vendors that you can buy this sort of hardware from is limited. And we're lucky that we work with BT, and BT use both Ericsson and Nokia. So we're working with both, or increasingly be working with both, and we're not in a kind of a bake-off style way, but they're maybe approaching the problem in a slightly different way. So it's been really interesting to be part of that. If you know about these things, Release 15 is the kind of last non-standard set of 5G standards. Release 16 starts to standardize things for 5G, and will mean that in the way that, in simple terms, that if you go abroad and you switch your phone on, it works and it just works properly. Release 16 starts to standardize some things like that across the industry and across the global village, so that you can actually you confidently know that your 5G equipment will work somewhere else. And they're working hard on these releases, and there's more to go. Personally, for us, we've learned that being your own mobile network operator is quite hard. There's a lot to do. Sometimes it's not obvious how to get things done, and working with Ofcom originally was quite time-consuming and difficult. I think they expected we knew enormous amount more than we actually maybe did. but their new processes are making it a lot easier and a lot simpler going forward, which really will help us out. So we're often asked this, and Simon touched on it a bit earlier. People would say to us, how much would it cost for me to get 5G in my factory? And my standard sort of response was, well, how big's your factory? Because it's really hard to work it out. One thing you absolutely need with 5G is you need really good coverage. You can't be in a situation where you've got a bit shady coverage and not very good. It's just not going to give you the data rates we've discussed and the new data rates coming up. So it's really important when you put 5G in a factory that you do a really good radio survey up front and you really understand the potential electrical noise and other issues you might find as a result of your building. So it's quite hard to work it out. We worked out that for roughly £500,000 you could install your own private RAN in a factory, and that would cover a large space. That's just from our own early days findings, and we looked at and tried the best we could to figure out hardware and installation costs. We also were interested in an idea where, if you imagine a business park, you might have 3 businesses on a park. There'd be nothing to stop them sharing a core site and having their own RAN. So as you've heard about network slicing and things like that, they could be confident they've got their own slice of network. They're confident they've got their own security, but they wouldn't have to have the whole cost of running a whole core. That could be shared between other people in the business park. When we looked at use cases, we've taken a view that to really look at a use case, it has to be a sensible value to the business. And what we've done is we've looked at use cases that would save £100,000 a year or more for each use case. There are lots of use cases that are fractional savings, and if you added up all these fractions, you would probably get make useful savings. But that's how we did it. We also try to understand what a normal mobile operator might do in terms of offering you support or offering some sort of a rented deal, and we think that's likely to happen. On the numbers we produced and the use cases we had, we really got payback in the sort of 2 to 3 years period, which is pretty good in terms of an investment case for an industry. And in fact, with Bosch, we're so pleased with the automated guided vehicles. They're looking at bringing more in to do other processes in the factory because it does, now it works well. They can see that it's a real bonus for them for the future. So that's it for me. If I've got this right, I think I click once more and that hands back to Linda, and then that's it, I think. Yeah.
Well done, Andy. Thanks very much indeed. And thank you also to Simon and in the background, Noel. We are going to open an open Q&A session now. I know that some of you have had a few problems with the logging in process through YouTube. My apologies from the team for that. We work really hard to make this stand up, but as I said, I hope most of you managed to get on, and I've caught the main body of the content, which is very interesting. Some of the questions I would like to kind of pose back to Simon, Noel, and to Andy, the killer application piece, particularly in relation to future test access, and certainly as far as BetaDen cohort program is concerned, we're very much hoping to be able to offer live test facility from the Malvern testbed going forward. Could you give us a bit of a flavour of kind of what that the test facility might actually comprise of for a BetaDen applicant?
Yeah, sure. So in the science park, we're lucky in that we have both indoor RAN and outdoor on a macro. And just to be completely clear, we have both 5G and we have private 4G. So if someone was looking to work in the science park, we would be able to give them modems and SIMs and access to. It's not come up in our conversation, but there is a really important part of 5G called the MEC, which is where you store your applications. So if a typical BetaDen person may want to load an app on our MEC and then might want to test it on indoor 5G and then scurry out into the car park and test it on essentially what is a remote site, i.e. our outdoor macro, But if they wanted to do comparative testing, we're lucky in that we have a high quality, high performance 4G private network as well. So I see Linda that it going like that, and that's what we've done so far, is allow people to run comparisons, run the outdoor, and they could go they could go off site down into Malvern or wherever they wanted and access it from there. But they can do the sort of early stage testing in a nice warm office in a desk with nice coffee and test it that way. Simon, would you or Noel, would you agree with that? It's about the size of it.
Yeah, I think we've got the communication. I mean, the facility is really the 5G communications, and probably, as you say, hosting for applications. But the use cases, I guess the clients would bring the use cases.
Correct. Yeah.
Would run over that communication channel.
Yeah,
and maybe devices as well.
Right. And our focus being latency and throughput, obviously, to ensure they get the best latency and the best throughput.
Yeah, dead right. And we're looking to configure the network to make it less latent. Is that such a thing? Make the latency better. And we're always looking to, and we are just to be clear, we are quite open for people who want to try and attack it and destroy it. It'd just be useful if they told us, so the other people using it know that it's being attacked and destroyed. So we're up for all of that, Linda, and my friends Noel and Simon would help me make sure we were offering you something that made sense.
Okay, thanks for that. We do have a question in. It is more a security by design bias question, but could I just again open this to the three of you? Security of data and communications need to be built in the outset. Do any of the panel have any thoughts on this in particular, because of today's topic being about the manufacturing industry and supply chains? So I know it does link a little bit to our previous Tech Tuesday, but any thoughts in relation to the 5G security by design element to new build?
Shall I set off, and then someone more technical than me can correct me? So I agree, and we've tended to talk about privacy and rather than secrecy, because secret means specific things to specific people, and that's fine, and I'm happy with that. So we've taken the view we've taken the first I think tenet we'd make is a private network is inherently easier to secure probably than a public network, because it's within your own control and your own gift. And we've worked hard with Kinetic in the forefront of this to make sure we understand the devices that we're connecting. So you'll all have heard horror stories of things like kids' toys that have a default password of 1234 that are essentially listening to you in your house and all of that sort of stuff, and you can't change it. And clearly you don't want things like that attached to your network. That just wouldn't make any sense. So we've worked along the 2 years to make sure that the devices that we take on, we understand how they're configured, we understand how we can modify passwords, and we check that it's actually operating correctly. And then we've built it like that. So we've tried to build it in at the beginning. The application that you would be accessing in an industrial context would live on a server on the MEC, or it could be in the RAN at your site potentially as well. So we've looked at everything that we can do to keep the data close at hand and understand all the devices and how they're attached. Simon's itching to say something, I think.
Yeah, well, I mean, it's a really important question and a really interesting one. I think, as you just touched on, Andy, I think the topology of the network is very interesting for some industrial applications, because they would see their data traffic, maybe even their usage as business critical. So locating that network in the customer premises and providing very secure access to it is part of the overall security. 5G and 4G and 3GPP that drive most of our standardization in these kind of cellular networks are working very hard on security. It's a very important requirement that went into the 5G standardization, and vendor products will be compliant to that. So in terms of the standardization, the design on those, then we'll be following the standardization. I think the other thing is that these networks can be used for business critical and maybe even mission critical applications. And we looked at the health and safety use cases as well, which might be considered to be mission critical. I think, yes, and then I think, Andy, I just echo what you were saying in terms of security and deployment. Is all very well having sort of zero trust models and security by design, which would come into the product development, but it also needs to be operated in a secure manner and configured in a secure manner. And then things like hardening of the systems for passwords and protocols and ports, etc., on firewalls is very important. And we do have a security solution around the Malvern Hills deployment, which was then scrutinized by Kinetic, who are experts in the field of security. So that's what we've been working on. I don't think it's something you ever finish, but it's something that we've certainly been focused on.
Yeah, I don't know if just one simple example of what we did when we were running multiple use trials. We gave each use case its own set of SIMs, its own set of credentials. So we were very clear that if we got 4 use cases, we've got 4 quarters of traffic, if you see what I mean, and then we can add it up and we know there's no other traffic on there. So we were able to slice it very accurately and watch and check traffic flows, understand protocols that were being used and try and understand it. It's really important. If 5G is going to fly in an industrial context, people need to get confident in it.
Okay, I'd just like to come to just one last question, if I may, before we close today. It's come in from one of our listeners. So, to what extent have you seen the 5G pioneers engaging with supply chain in ways that generate new service opportunities for suppliers? There seems to be a trickle-down effect is really important here. Okay.
I think that question, if I've understood it correctly, so the answer for me is not much so far, but I think there's an increasing start in it. So we would be delighted to see more people come along, and I think Ericsson would also be delighted, frankly, answering on behalf of Ericsson. Horrified look, but to more people to build cool devices that attach to these networks and use them, and more people in the supply chain actually building. If you go back to the early days when you used to pick up a BT telephone and turn it over, the little green spot on the bottom, didn't it, saying it was able to be attached to BT's network, was approved for connection to that network. I think there's an absolute opportunity for people to build devices that are 5G ready and 5G out of the box. So you can, and actually going back to the previous, with security as part of it. And I think hopefully I've got the question right, but as part of the supply chain and maybe smaller companies, I see from my maybe quite fortunate position of talking to Ericsson and BT and people like that direct, I think they're up for that. I think they're up for people bringing things and using these networks, because they are going right back to the beginning. This is not just another G. This is a new world of people start to talk about heterogeneous networks of SATCOM, of 5G, of 4G, of the whole lot, all becoming one big giant everything everywhere. So I'm careful to steal he's slogan there, but a network for all occasions, right? And I think there's an opportunity for people to build devices to attach to that. I'm sure that it'd be welcomed by the manufacturers.
Okay.
Can I add a word, or?
Just a final comment there, Simon, would be great. Thank you.
Yeah, I don't think we see that killer use case or killer application, and probably we won't find it in 5G. I think it's more about providing a network that's flexible enough to take multiple use cases and multiple applications, and to do that, we need an ecosystem of devices and applications, and there are various players in the frame today, but there's room for plenty more, and I guess working through Beta Den is one way of doing that. Also, I comes to mind Digital Catapult are also doing something in the UK that's incubating and promoting in industry to come together to work on this kind of thing. So that was from me, Linda.
Well, thank you all. I think we're going to wrap there. Fantastic contribution from Andy, Simon, and from Noel's small contribution there, but thanks, Noel, for being on the line and supporting this too. I know that possibly there will be questions that will drop out of this talk, and I know that we'll get the support from the 5G team. So from BetaDen's point of view, this again is pretty critical, as you can probably imagine. And I just want to kind of, the slide that's up on the screen is really giving you a flavour of our topics for our Tech Tuesdays we're planning now for 2021, starting with securing government for February's talk, and then moving through, as I said, every 2 months through 2021. And hopefully by this time next year, we'll be in a much clearer position around global technology growth and how the impact of not just 5G, but edge computing and the, as I said, the industrial Internet of Things related to this world all will be making much clearer pathways. BetaDen, from BetaDen team, as I said, cohort 4, we do have application campaign starting in the next 10 days. And if you or any of your own contact network are either individuals or small tech companies or scale-up companies that are looking to develop next generation technology, but also with access to a commercial 5G testbed and with our relevant stakeholder consortium community, including Ericsson, BT and others, then please get the word out for us, because as a small, young accelerator, we're pushing hard, and this opportunity is quite unique. The times we're living in, if ever there was a time to act on this development window, it's now. So again, please, we'd appreciate some help from any of you listening today that can really help us drive the real talent towards BetaDen to help us drive a really strong cohort for March 2021. Thank you for your time today. Thank you to our contributors, and thank you to you, our listeners. If you want to know more, please contact us. If you have ideas or you would like to speak yourself on a particular topic, please let the team know. Thank you. Signing out now. Let's close for today.